there has to be identification of optimal strategy. The how much the strategy use of life, how much the first strategy, that is useful life, should be used, and how much this end of life strategy should be implemented. There has to be a right balance between them, and how much it should be. So we have to now identify the optimal strategy. So having quantified the main external factors, it is possible to identify the strategies most appropriate to the product for varying its durability and that of its component. So the product should be durable enough, long enough, and it should also be recovered at the end of its life. A series of significant evaluation can be made by comparing the physical life with the replacement life. Now there is another definition which has come here, that is called as replacement life, defined as the period of time for which the product is effectively usable. So this is a new concept now, which is saying that replacement life, that the product should be replaced after 2 years of service, 2.5 years of service, or 3,000 hours of service, or 4,000 kilometers of its run, and so on. Replacement life. This is comparable to the period of time the product is present on the market up to its definitive replacement, thus incorporating all external conditions considering above. So whatever lives and everything which I have considered, based on that, this definition of replacement life has to be found or defined. Physical life represents the predicted duration of product's full efficiency, whereas replacement life represents its effective span. So I have already defined this physical life, what it is saying. So there is a comparison now made between physical life. Physical life, I told you that it is the life of the product. Here somewhere, yeah, it's lasting. Okay. Uh, Physical life, what is it? It is the period of time for which the product is expected to physically last, maintaining its functional performance. Okay, so it may even last by using repairing and maintenance things. It may last and it may give its functional performance. But there is another concept, and that is saying replaceable life. And what it says, physical life represents the predicted duration of a product's full efficiency, while replacement life represents its effective lifespan, conditioned by factors such as technological and economic obsolescence and other external factors. So it is saying that replacement life is earlier than the physical life of the product. So in order to understand these things, two things now, physical life and replacement life, we have this figure here. What it is saying, again I am repeating this because the physical life and replacement life are required here. Physical life and replacement life. So I am repeating this again for you. What it says that the physical life represents the predicted duration of a product's full efficiency. जब तक वो काम कर सकता है तब तक वो काम करेगा, that is physical life of the product. While replacement life represents its effective lifespan, conditioned by factors such as technology. So if replacement life मतलब टेक्नोलॉजी चेंज हो गया तो इसका रिप्लेसमेंट लाइफ हो गया, मतलब अगर टेक्नोलॉजी 8 साल के बाद चेंज होता है तो उसका रिप्लेसमेंट लाइफ कितना हो गया, 8 साल. उसका फिजिकल लाइफ 15 साल भी हो सकता है, वो चलेगा 15 साल भी, लेकिन उसका फंक्शनैलिटी चालू है इसलिए वो फिजिकल लाइफ उसका ज़्यादा है. लेकिन इट इज़ नॉट एज पर द टेक्नोलॉजी, it is not as per the economic obsolescence, or it is not about as per the external factors which we have discussed now. So these are the two life, physical life and replacement life. So here you can see a graph is plotted between a replacement life and a physical life. Okay, and it is identification of optimal strategy. So what should be the optimal strategy when it should be replaced, or when it should go to the recycle bin. On the basis of this comparison, a distinction can be made between two types of useful life extension strategies. What are the two life extension strategies? We have already discussed. Maintenance, repair, and service operation constitute strategies on the physical life. So this is physical life extension strategy. मेंटेनेंस करोगे तो उसका फिजिकल लाइफ बनेगा, रिपेयर करोगे तो बढ़ेगा, सर्विस दोगे तो बढ़ेगा, फिजिकल लाइफ बढ़ते रहेगा. Upgradation and but now what it is talking about, another life extension strategy is replacement life extension strategy. It is saying that it should be upgraded, and adapted of the product constitute strategies. So can you, if you have a product, now can it be upgraded? If you can upgrade the product, its life will increase, and it is replacement life extension strategy. So the figure, this figure shows how depending on the product type, it is possible to identify the favorable condition for extending the useful life. So you can see here, feasible life extension is needed. Now, if there is a product, whose replacement life is more, but if its physical life is less, its replacement life is more. So it needs useful life extension strategy. Another case, if the physical life of the product is more, but the replacement life is less, physical life is more. So if the physical life is more, you can have a product here where its replacement life can also be more. But if the physical life is less, then you can have a product here where its replacement life can be extended. So it is giving opportunity for useful life extension. So the same thing is again explained here for physical life extension strategies. If physical life extension is needed here, how much is the physical life here? If I start this as 0 and the physical life is extending or increasing on the right hand side, this is 0, it is increasing. So it is a short physical life and it needs some extension in the physical life. Physical life itna hona chahiye because replacement life is high. So for the physical life extension strategies, this condition correspond to the long replacement life. देखो रिप्लेसमेंट लाइफ बहुत बड़ा है, यहाँ से 0 से स्टार्ट करेंगे तो रिप्लेसमेंट लाइफ 10, 15, 20, 25, 50, 60 ईयर्स, बट उसका फिजिकल लाइफ ही कम है, तो फिजिकल लाइफ हैज टू बी एक्सटेंडेड. फॉर फिजिकल लाइफ एक्सटेंशन स्ट्रेटजीज, दिस कंडीशंस correspond to the long replacement life. Long replacement life मतलब indicating that the product may be used for a long time, and a short physical life. So a product which has long replacement life and short physical life, it needs some physical life extension strategy. Whereas conversely for replacement life extension strategy, अभी कुछ प्रोडक्ट को replacement life extension strategy is needed. So here physical life is more, but the replacement life is not more. So it has to have more replacement life. Conversely, for replacement life extension strategy, this condition correspond to a short replacement life and long physical life. Short replacement life and long physical life. So it should be upgraded. These conditions not only indicate the inappropriateness of planning, maintenance, and service interventions, but also reveal a poor design. So it shows that if the products are like such, like इसका physical life बहुत कम है, this is having a capability of more replacement life. It is having the capability of upgradation, but उसका physical life ही कम है, वो product जल्दी खत्म हो गया, मतलब it is not properly designed. Or there are some products which is having long physical life, इसका physical life ज़्यादा है, लेकिन उसका कुछ use नहीं है ना, क्योंकि technology change हो गया, so replacement life जल्दी हो जाएगा उसका. So it means that the products are not designed. So what it's saying that these conditions not only indicate the inappropriateness of planning, maintenance and service interventions. उसका मेंटेनेंस बराबर नहीं हुआ है या फिर सर्विस प्रॉपरली नहीं हुआ है, but also reveals a poor design. So design is not correct. Design is poor, unsuited for the predicted short span of effective use. So this is the condition here. Which is not correct. This has to be improved. And for improving this, we have this sketch, which will improve the strategies. So optimization of the strategies. So this we'll see in the next lecture. What is this? Let us go through this once again. So it shows here that there are some products which are not designed properly. वो जल्दी टूट जाते हैं जबकि वो ज़्यादा चलना चाहिए, और कुछ टूटते ही नहीं है, खराब नहीं होते हैं, लेकिन वो टेक्नोलॉजी के लिए कि वो फिट नहीं है, वो बुरा नहीं टेक्नोलॉजी के हैं. So this is the issue. So examples of latter are over dimensioning or using unnecessarily high performance material. ओवर डायमेंशनिंग, इसका डायमेंशन बहुत ज़्यादा दे दिया। अगर अगर 10 mm डायमेंशन चाहिए तो 12 mm 15 mm डायमेंशन दे दिया, तो टूटेगा ही नहीं, उसका फिजिकल लाइफ बहुत रहेगा। बट फिजिकल लाइफ बहुत रहेगा लेकिन उसका रिप्लेसमेंट लाइफ तो खत्म हो गया। अगेन टेक द एग्जांपल ऑफ दैट चप्पल और शू, आई एम जस्ट यूजिंग द चप्पल वर्ड। चप्पल अगर बहुत ज़्यादा थिक मटेरियल दे दिया, वो टूट ही नहीं रहा है, लेकिन अभी वो टाइप का चप्पल कोई यूज़ नहीं करता है। सबका चप्पल अलग है और मेरा चप्पल वही पुराने स्टाइल का रहेगा, तो कुछ फ़ायदा ही नहीं है, मुझे वो रिप्लेस करना चाहिए। तो बहुत ज़्यादा मटेरियल दे दिया उसमें, क्योंकि टूट ही नहीं रहा चप्पल, लेकिन वो पुराने स्टाइल का हो गया, अभी कोई भी पहनता नहीं है, तो आई एम द ऑड मैन इन दैट। So examples of latter are over dimensioning or using unnecessarily high performance material. This high ineffective situation can be remedied through the upgrading or adoption of product. So this situation has to be this is ineffective situation. This has to be solved. Okay, now talking about this and this area, talking about these two area, what it says, the other areas of the graph indicate conditions of equilibrium between the two factors, representing the result of good design, wherein the design choices were such that the physical duration of the system was calibrated on its expected effective life. Now, what is the condition here? The condition here is physical life is less and replacement life is less. ओके, मतलब उसका टेक्नोलॉजी चेंज नहीं हो रहा है, टेक्नोलॉजी चेंज नहीं हो रहा है तब तक मतलब उसका फिजिकल लाइफ भी कम है। कंसिडर हियर आल्सो द डिजाइन इज गुड, व्हाट इट सेज, इट्स फिजिकल लाइफ इज मोर, its replacement life is also more. So the product is such that it is strong, it is not it can be used for many years, and at the same time there is some upgradation possible, or it is not old fashioned or old technology product, because maybe there is less improvement in the technology. Just to take the example of electric iron. Now if I compare it here, पहले के ज़माने में आयनिंग कैसे होता था, उसमें कोयला वगैरह डाल के करते थे, सो उसका लाइफ तो बहुत था ना, वो तो टूटेगा ही नहीं, वो कोयला वाला जो भी आयन था वो टूटेगा ही नहीं। बट यू सी टेक्नोलॉजी हैज़ बीन चेंज नाउ, वो सबके लिए यूज़ नहीं कर सकता है, तो उसको दैट इज़ रॉन्गली डिजाइंड। ओके, दैट इज़ वन ऑफ द एग्जाम्पल. So I will stop with this sentence. The particular condition is generally referred to as a condition of environmental efficiency, where the resources used in manufacturing the product are gauged on the basis of the effective uh, uh, exigencies, मतलब effective demand, avoiding over dimensioning and consequent pointless wastage. So when you are talking about this product, this or this, they are properly designed. They are properly designed product. And if we are talking about this product, which is which is coming in these corners, they are not properly designed. So if this is happening, it's okay. So this should happen here also. This should happen here also. So what can be done? So what can be done, that is explained here in this slide. So this we'll see in the next lecture. What should be done so that the product should be designed in such a way that optimal strategies are. The design is based on the optimal strategy. Yeah, here it is. Physical life represents the predicted duration of the product's full efficiency, while replacement life represents its effective lifespan. Okay, physical life represents the predicted duration of a product's full efficiency. Like it was predicted that this maybe calculator, for example, a calculator. That calculator will last for say 20 years. 20 साल तक उसका calculator को कुछ नहीं होगा. So that is its physical life. But what is replacement life? It represents its entire effective lifespan. Maybe that calculator is not working because there is some issue with the power connection. Maybe that battery is not working, or that size, the battery which is put in the computer, in the calculator, that battery is not working. If it is not a solar operated, then the battery is not working, or that type of battery is not available now. So because of that, what happens? The effective life of the calculator is over. So it has to be replaced. So that is called as replacement life. Okay. So here we can see physical replacement life is along y-axis and physical life is along x-axis. Now, if you see this here, it is gauge duration and here it is gauge duration. I will explain these two quadrants later on. First, we'll see this quadrant. replacement life extension needed. Now see, physical life of the component is much more. Physical life of the component is more, but replacement life is less. You can see what is the replacement life here, till here on the y-axis, no, till here. And what is the physical life? See, it is 0. It is so long. So physical life is more, but its replacement life extension is needed. Just consider an example of a stool, the stool on which you sit in the college. Okay. Now, if these stools, their physical life is more, the stools are really now also maybe after so many years they are still working good, but then its replacement life is over. Replacement life is less. Why replacement life is less? Because maybe that stool is not comfortable for you to sit, or maybe its height is not proper. It is slightly less in height or slightly more in height. Also you can compare the example, consider another example of the desk and benches. Okay, those desk benches in our college, maybe their physical life is more, but then they are not comfortable for you to sit for 8 hours, means we need replacement. So here there are products whose physical life is more. The physical life can be more because of two reasons: either the material selected and the design is good, or the second reason can be excessive material is added. Then that's why the life of the component is increased. Now consider this case here in this quadrant. It is saying that its replacement life is high, but its physical life is less. See, this is the physical life on horizontal axis. So its physical life is still here only. Even though its replacement life is high, मतलब ये चलेगा 50 साल तक चलेगा, लेकिन उसका फिजिकल लाइफ ही कम है. What do you mean by physical life is less? वो टूट गया part. It is deteriorated, or it is not functional now because it has broken somewhere from somewhere. But it could have been lasted much more. So in that case, its physical life is less, but replacement life is more. So then this is not correct. This should not happen with the component, because if this is happening means there is something wrong in the design. Therefore that's why there is written opportunity for useful life extension. So life extension is needed in this case. Now consider this quadrant. What it says? It says that the gauged duration means it has anticipated that the life of the physical life of the product will be only, say, if I say 10 years here, will be only 10 years. So it is 10 year, and its replacement life is also 10 years. Just to okay, I will reduce the span just for understanding the example. Let us consider a garment, or maybe a shirt, or maybe jeans, whatever. Like for example, a jeans, life of jeans is, let us take for example 3 years. Okay, 3 years is the life of jeans. So it is lasting for 3 years, and within 3 years period of time only, the fashion has been changed. Since the fashion is changed, so the jeans will be old fashioned now after 3 years. But anyway, that jeans has been torn after 3 years, and we are not going to use it anymore. So it is an example of gauge duration. मतलब expect किया था 3 साल उसका life रहेगा, और उसका replacement life भी 3 साल ही रहेगा. Had it been, see, had the life of the jeans be say 20 years, तो 20 साल तक फटेगा नहीं. But after 3 years you will anyway replace it, because that is not the fashion, current fashion now, right now. Okay, so in that case, if it is 3 years expected life, that is physical life, and 3 years replacement life, it means it is in the gauged duration. So these products are designed properly. Similarly, you can see here, there are certain products which are gauged duration in this quadrant. So its physical life is more, and its replacement life is also more. I can give an example of maybe our home, which is manufactured, and its physical life is say 50, 60 years, and its replacement life is also maybe 50 to 60 years. Replacement life in the sense, not an internal replacement, but demolishing the entire building and then rebuilding it. So it is more, around 50, 60 years, or even more than that. And its physical life is also more. Okay, so if those are the things which are coming here, then we can call it as a gauge duration. So in this quadrant, that particular product is properly gauged, its duration is properly gauged, its duration is properly anticipated, and it was properly designed material. Again, consider the example of home. Suppose life of home is around only 10 years only. 10 years. The cost required for building a house or home is too much. And if its physical life is 10 years, but its replacement life is high, okay, it can be replaced after 20, 25, 30 years, then it is not a gauge duration. It falls in this, and it says that physical life extension is needed. When the product falls in this category here, we will see that physical life extension is needed, and if it falls in this category, we will see that replacement life extension is needed. So based on this, we need to identify the optimal strategy. So for identifying optimal strategy, this also we have discussed. This is the another figure which is providing uh, us the optimal strategy. What is the optimal strategy? It says that if the physical life of the product is less, अगर वो चलना ही वाला है 5 साल के लिए, then its replacement life should also be less. But then this is not possible because replacement life does not depend on physical life. So I'll put it in another words. If the replacement life of the product is around 5 years, maybe after 5 years that product will not be of any use to you. Maybe that product will not be old fashioned product. Maybe uh, water that will not, we cannot continue with that product. So why to increase the physical life of the product? Why to add so much material in the product that it will not be, it can be used for 20 years, where you want to end it by in 5 years. Okay, that is the concept here. So area 1 represents a condition where the product whose effective useful life and presence on the market is expected to be short. Okay, that's what I have told you. Whose effective useful life and presence on the market is expected to be short. Mobile phone, for example. Mobile phone, its replacement life is say 3 years. So this is representing 3 years. So why to make a mobile with such a material, costly material, that it will last for 10 years? Make a mobile phone which can last for around 3 years only. Okay, if you are adding more material in it, if you are adding heavy material in it, if you are adding costly material in it, so what will happen because of that? Its physical life is still there, but then its replacement life is over. So then that part we should go for recycling. If it will fall in this region, then so that is what is said here. Area 1 represents the condition where the product whose effective useful life and presence on the market is expected to be short is composed of rapidly deteriorating material or component. ऐसे मटेरियल से बनाओ कि जो खत्म हो जाएगा 3 साल में या 4 साल में, वॉट इज प्रेडिक्टेड. This represents a condition of gauged duration and therefore in principle a coefficient. So you have gauged, you have anticipated, you have identified that the technology, particular technology will last for maybe 3 years only. So you have used the material accordingly. Let us consider an example of a toy. A toy, any child will use a toy for maximum of 6 months. So if it has to be manufactured with such a material, thin material, and maybe low cost plastic or low quality material, such that it should last only for 3 months, sorry, 6 months. Okay, so it has to be properly gauged. So you manufacture, while manufacturing, select the material in such a way that the life, you anticipate the life, you anticipate the replacement life, you anticipate the technology, you anticipate the innovation, you anticipate what whether the need of the product, and then you design the product. And if it is properly gauged, then it is called as eco-efficient product. It is a product which is efficient from the environmental point of view. At the end of life, any integral component are potentially reusable in other products, but the most probable recovery strategy is that recycling the material where possible. See now what it is saying that at the end of life, in this case, number one, any integral component are potentially reusable. Now if that toy, if the toy is not still not deteriorated, if it is still good, then what can be done? Give it to send it back to the company, or if you send it back to whosoever is collecting it, then those parts, maybe the springs are good, maybe the knobs are good, maybe the tires are good. Okay, then those parts can be reused in the manufacturing of new component. Okay, so at the end of life, any integral component are potentially reusable in other product. But it is saying that the most probable recovery strategy is that of recycling the material where possible. So instead of reusing it again, the most optimum strategy or the good strategy here is to recycle the product. So keep it life keep its life short as per the requirement, so that that can be recycled, and then there is no need to reuse the component in some other new manufacturing of new component. Then the area 2, what it says, area 2 represent the condition where the product whose effective useful life and presence on the market is again expected to be short, and is composed of long lasting and functionally efficient component. Now if the effective useful life in the market is short, see replacement life, मतलब इसके बाद में इसका टेक्नोलॉजी खत्म हो रहा है. For example, shoes, if you are wearing shoes and maybe the design of shoes is going to change after every 2 years, and if you don't want to continue with those shoes, so what you will do, you will throw those shoes. But if you see here in the stage 2, here stage 2, if the physical life of the shoes is good, you can continue with the shoe. You can continue with the shoe, it is not torn or it is not undersized to your fit. Then even though its replacement life has end now, because new technology has come, or not technology, new design of shoe has come, but its physical life is still more, वो अभी भी चल रहा है, खराब नहीं हो गया. Then it is a case here of area 2. It represents the condition where the product whose effective useful life and presence on market is expected to be short. It is expected to be short, but it is composed of long lasting and functionally efficient component. So it is made up of such a component which is long lasting. 2 साल चलने वाला शू 10 साल तक चलेगा. मतलब you have added extra material to it, you have given more strength to it, and you have invested much in that product. So it is not a good investment. It is not a good investment, because it should not last for more than what 2 years or 3 years, like that. At the end of life, the product may still be fully efficient. See, end of the life. Which end of the life? Replacement life. The product is still fully efficient, but as a result of external factor, cannot easily be reused because it is obsolete. It is obsolete. Okay, so this is the issue with this. It means that this is not a proper design. This is not a proper design. Many of the components can potentially be reused as spare parts or in other products. So what can be done? Some of the parts has to be reused in some other component, some other part. The most probably recovery strategy is again the recycling of the material wherever possible. But the most probable recovery strategy is what? Recycling. But in this case, since out of 10, 9 components are still functioning, they are still good. So what if it is to be disassembled, then the parts can be removed and those parts can be used as uh, input of to the new product. Okay, so here we have seen that in section 1 it is a good design, here it is not an optimal design. Then area 3. Again, area 3 is not a good design. We have already seen in the earlier sketch. Area 3 represents the condition where the product whose effective useful life and market presence is expected to be long. मतलब टेक्नोलॉजी चेंज नहीं होने वाला है, वो प्रोडक्ट बहुत दिन तक मार्केट में रहने वाला है, एंड सो ऑन. बट देन इट इज कंपोज्ड ऑफ रैपिडली ड्यूरेटिंग कंपोनेंट, लेकिन उसका लाइफ खत्म हो गया, वो टूट गया बीच में, एंड इज नो लॉन्ग लास्टिंग इनफ, और वो टूट गया एंड देन इट कैन नॉट बी फर्दर यूज्ड. Consider an example of tire of a vehicle. The tire of the vehicle, its replacement life, it can be a high replacement life if it is, but it is made up of a material which is rapidly deteriorating. The rubber quality, if it is not good, then this part which is having high replacement life, what is the car of life, average car of life if you take 10 years, then we expect that the tire should also last for 10 years, but the life of tire is say around 4 to 5 years. In this case its replacement life is high, वो चल सकता है और 10 साल तक चल सकता है, but it is made of such material that it is physical, its physical life is over, वो टूट गया, वो फट गया वहां से. Okay, that is an example here in this region. There is a concept of remolding of tire. If the tire is not used to its full strength, then it can be remolded. It can be remolded, and again it can be used as a not a new tire but as a second hand tire. It can be used and it can again last for few more years. At the end of life component that at the end of life component that are still efficient can be reused in the manufacture of a product of the same type. So I have given you example of a tire now. For the remaining component, only recycling of material is possible. Now, if its life is more, but then it is not lasting, its physical life is not much, then it can be it can be reused. It has to be reused only. And the and the final and the fourth zone here is again a eco-efficient zone where the replacement life is high and the product life is also high. So I had given you example of land, I think, or home here, where area 4 represents the condition where the product whose effective useful life and market presence is again expected to be long. It's expected to be long, is composed of long lasting material and functionally efficient component. Okay, that's why this is a design which is eco-friendly design or what is that word? Eco-efficient design. Eco-efficient design. So this is the case which is representing eco-efficient design similar to case 1. So what have we understood from these 4 zones or 4 corners or 4 quadrants? We have understood that if the material replacement life is less, then make it with a component which is not having more physical life. And if the replacement life of the component is more, if it is more, then its physical life should also be more, and it falls in this fourth zone. So first and fourth zone are the zone where the design is perfect, and if you are designing a component in the zone 3 or zone 2, it means your design is not correct, your design is wrong. So this is the optimal strategy that has to be followed. So like area 1, this represents an principle, this represents in principle an eco-efficient condition of gauge duration. This one. If at the end of life the entire product is fully efficient and if the length of the replacement life will allow it, in this case it is possible to directly reuse the entire product. So if at the end of life the entire product is fully efficient, sorry, if the physical life is over, but the product is still fully efficient, it is properly functioning, and if the length of the replacement life will allow, and if the length of replacement life, see, this is the end of replacement life here, and this is the physical life. But if the physical life is over now, but physical life which is described is over, which was earlier predicted is over, maybe suppose 10 years was the physical life, and still if it is functioning properly, and if the replacement life allows to use the product, if the replacement life allows to use the product, if for example fan, you must have seen fan for many years, they are still in the home. We don't change it occasionally as we change mobile phone or as we change our clothes. We don't change fans like this, they are there for many years in our home. So its physical life is more, and also the technology is allowing it to you to be used, its replacement life is still more. So this is the case of that fourth one. So we can increase the use of that product. Okay, we can increase the use of that product. So in this case, it is possible to directly reuse the entire product. So we are using it again. Okay, that is the fourth condition. So if you have noticed here what is written, reuse of component, reuse of component, reuse of component, and here it is saying reuse of component. Another thing is recycling of material, recycling of material, recycling of material, but it is saying reuse of product. Instead of saying recycling of material, it is saying reuse of product. Matlab reuse matlab you continue using it, or maybe someone else is using it, but it is being reused. So this is the optimum strategy here, either this fourth one or this first one. But the design, if the design is such that it is falling in this category 2 or category 3, then it is not a good design at all. So this would represent the most efficient strategy for environmental protection unless the use of the product involved a significant environmental impact that could be avoided by using a new, more efficient product in this instance. So it is saying that, okay, fan, for example, its physical life is not over, its replacement life is not over. But if you are having a new product now, new product which is more efficient, maybe if the fan is now consuming less power, less electricity, if there is fan like that, then you can go for replacement. Otherwise, this would be the efficient strategy or optimum strategy. As an alternative to direct reuse, it is possible to reuse some of the components, or in case you can use some of the component also. Uh, if for example, fan, what are the parts in the fan? There is a motor, then there is a capacitor or condenser, and then there is there are parts like blades and rods and all those things. So you can, if you don't want to go with it, you can reuse some of the components. Some of the components can be reused in a new product. That's it. Finally, it is always possible to resort to recycling the material if feasible. And वो भी नहीं करना है, तो final step is even though the product is good, even though the technology allows you, but you are bored of that use of by using that particular product. वो खराब भी नहीं होता है, टेक्नोलॉजी से रिप्लेस भी करने की जरूरत नहीं है, अच्छा प्रोडक्ट है. इफ यू आर बोर्ड ऑफ इट, द फाइनल ऑप्शन इज टू recycle the product. It can be recycled, then the metal can be melted and again it can be used for making a new product. So this is all about the life cycle environmental strategies and considerations for product design. Okay, so this based on these strategies, you can consider how to design the product.